Welcome to Master Concepts in Chemistry. In this lesson, we'll discuss the types of change matter can undergo. Matter can undergo two types of change. One is called a physical change, and the other is called a chemical change. So let's look at what a physical change is. So what is a physical change? It is a change with no change in chemical composition of substance. That is, no new substance is made from the starting materials. So here, let's look at the key term. So the key term here is no change in chemical composition of substance. So this means that if your substance undergoes a change of state, it's still the same old substance. You haven't turned it into a new substance. So if water in the form of ice, if it melts and you get liquid water, it doesn't mean because ice changed its state from solid to liquid, you have made a new substance. No, it's still the same old substance. So changes of states are physical changes. Okay. So we don't make a new substance in a physical change. So what are examples of physical changes? So let's look at some examples of physical change. So let's say we have our ice, look in the form of ice. So it will melt and will form liquid water, or water if you want to call it. And then this water will boil and will form water vapor, which sometimes we call steam. So we are heating, so we are applying heat in this direction. So heating in this direction. Now we can also remove the energy. Remember, heating means adding energy to our ice so that the molecules of water will vibrate a lot more. Now we can also travel in reverse, whereby we'll be cooling. So cooling means removing energy by decreasing the temperature. And heating means applying energy by increasing the temperature. So if we are traveling in reverse, cooling, our water vapor will get to a certain point whereby they will start to condense. So condensation. And then as we keep cooling, it will get to a certain point whereby they'll freeze. So the physical changes or the physical processes that really cause these physical changes are at these points where I'm circling. So melting is a physical change. So melting is a physical change. Boiling is also a physical change. Now, if we go in reverse, condensation is also a physical change. Freezing is also a physical change. So you see that. And we can add others. So we can also add evaporation. So evaporation also is a physical change. So evaporation of water is a physical change. Okay, so these are physical changes. Melting, boiling, condensation, freezing, evaporation. They're all physical changes. Okay. So as you've seen, if you start heating ice to get to its melting point, then it will melt. And as you keep heating, the liquid water will get to its boiling point and it will boil. Okay. And as you are cooling, the water vapor will get to its condensation point and it will condense. And usually the boiling point and condensation points occur at the same point. Similarly, the freezing point and melting point also occur at the same point. The only thing is that in one direction, we are adding energy to increase the kinetic energy of the molecules, and in the other direction, we are removing energy to reduce the kinetic energy of the molecules. And keep in mind that as we are increasing the kinetic energy of the molecules, as we're applying heat, the attractive forces between the water molecules also decrease, weakening the attraction between the water molecules. As a result, we can easily have these phase transitions from solid to liquid to gas. Okay, so these processes are examples of physical changes. So how can we tell the difference between a physical change and a chemical change? Or how can we observe a physical change when particle models are drawn like this? So as you've seen here, this is our before picture, and this is our after picture. So if you compare the water molecules, I'm just assuming, yeah, it's written a water molecule, so we know it's water molecule. But even if it wasn't written, just look at the molecule you have in the before picture and the molecules you have in the after picture. You notice that they are still the same molecules. So the only difference between the before and after is just the amount of empty spaces we have in each model. So we can say this model is depicting a gas as the picture tells us. And we can also say this model is depicting a solid as the distance between the water molecules reduce. But again, this model here is an over exaggeration because water molecules, when they freeze, they form hexagonal structures. So just keep that in mind. So this is just to emphasize the difference between physical and a chemical change. And we'll look at a chemical change later on. But yeah, we'll connect the two as we get there. Okay. So what is a chemical change? So a chemical change is usually a change with a change in chemical composition of substance, meaning a new substance is made from the starting material. So what are the key terms here? So a key term here is in the chemical change, you have a change in composition of your substance. So you turn your substance into a new substance. So what this means is the bonds that hold the atoms together to form your substance. When that substance undergoes a chemical change, those bonds are broken and reform in new ways to form a new substance. So that's what this is saying. So what are examples of chemical changes? Yeah, examples include chemical reactions, basically. Chemical reactions are, chemical changes. So if you burn a candle, the candle burns and then produces carbon dioxide and water. So these are examples. So let's look at a particle model to explain this in detail. So here we have a particle model depicting a chemical reaction, meaning a chemical change. So how can we tell whether this model actually depicts a chemical change? So what you have to keep in mind is this is a chemical equation. So you have an arrow here. So the arrow separates the chemicals on the left side and then the chemicals on the right. So we call the chemicals on the left side, we call this reactants. So these are our reactants. And the ones on the right, we call our products, but we just have one product here. So I just say product. So as you can see here, we have reactants and products. Now, if you read the names of the reactants, we have hydrogen molecules reacting with oxygen molecule. So the hydrogen molecules, you see that they are connected by a green line. This green line is just showing that a bond connects them. So the two hydrogen atoms here are connected by a bond, another molecule of hydrogen here, and the oxygen, we just have two of them, but they are connected by a double bond. So this tells you that, oxygen is connected, the two oxygen atoms are connected by a double bond. Okay. So what happens when hydrogen and oxygen react? They form water. So look at the molecule of water. So on the reactant side, the oxygen atoms were together. The two were bonded together. But on the product side, the oxygen now bonds to two hydrogen atoms. Okay, so as you can see, bonds were broken on the reactant side and bonds reformed on the product side. But as they reformed, they formed a new substance. So we now have water. And the properties of water, of course, are unique compared to the properties of oxygen and hydrogen. Okay, so that is what we say. That is why we say in the chemical change, there's always a change in chemical composition of your substance because bonds are broken and then new bonds are formed. And remember, these bonds are what hold your hydrogen atoms together to form hydrogen molecules. So if you break one, you no longer have a hydrogen molecule. You just have hydrogen atoms. Okay, so that's what we mean when we say you break the bonds holding the atoms together in a molecule. Okay. So in a nutshell, for a chemical change to occur, bonds must be broken and bonds must be reformed. Okay, so that is what you need to keep in mind. So if we compare the particle model of our chemical change to the particle model of our physical change, you see that there's a clear difference. Okay, so physical change, our molecules are the same before and after. In a chemical change, our molecules are different before and after. Okay, so we have a change in composition in a chemical change, but we don't have a change in composition in a physical change. Okay. So thanks for watching.